All right, we're going to look at something that seems like it's going to be completely different, but it's going to be a very important idea shortly when we look at second order linear equations. So we're going to define and look at complex numbers. So the idea is we're going to have two definitions. First is I'm going to define I to be the square root of -1, because why not? And the important thing to recognize is that if I square both sides, I get that I squared is -1. Okay. The most important thing about this is it's just a number. It's a weird number, but in the end of the day, it's just a number. I'm going to use this to make the next definition. The next definition is something called a complex number. So a complex number is a number that can be written as a plus bi, where a and b are real numbers. Okay, so for example, we can call z1 3 plus 2i. That's a complex number, and it's a constant. I have z2 minus 4 minus 7i. That's a complex number. Okay, and from this, we can define all the usual operations. So for example, if I take z1 plus z2, that's 3 plus 2i plus minus 4 minus 7i. And what I'm going to do is I'm going to take the parts without an I. We're going to call that the real part. Treat that separately. And then I'm going to take the parts with an I. So I'm going to have 2i and minus 7i. I can write like that. And now I can deal with each of these things separately. 3 minus 4 is minus 1. 2 minus 7 is minus 5. So z1 plus z2 is minus 1 minus 5i. I can also define multiplication. And this is going to be a little trickier in that I've got to obey the laws of algebra. So I'm basically taking the product of the sum of two things, so I've got to FOIL this out. So let's do this. Let's take 3 times this thing plus 2i times this thing on the right. And now I can multiply those out. So I've got 3 times minus 4 plus 3 times minus 7i plus 2i times minus 4 plus 2i times minus 7i. So it becomes minus 12. 3 times minus 7 is minus 21. 2 times minus 4 is minus 8i. And now I've got to be a little careful here. 2 times minus 7 is minus 14. But then I've got an I squared, or I times I. And now when I carry that through, I squared is minus 1, so I get a minus times a minus, becomes plus 14. And now I can collect the parts without an I, so that's minus 12 plus 14 is 2. And the parts with an I is minus 21 minus 8i is minus 29i. Now, we can also do division. So if I do the division, I get something in this form. This is a little problematic because remember we defined a complex number to look like something like a plus something times I. And that is not in this form. So the question is can I put it in this form? The answer is going to be yes. And there's a trick. And the trick is this, is I'm going to focus on the denominator. If I can make the denominator equal to a real number, my life is going to be nice. And the way to do that is I'm going to take the part with where I'm multiplying by I and flip the sign so that if it's negative, it becomes plus. If that had been a plus, I would have made that a minus. So I'm just multiplying this by -1, putting it there. Problem is I can't just multiply that by itself. I have to multiply by 1 in a clever way. So now I'm multiplying by 1, and I'm going to break these up into 2 pieces. I've got the numerator, and I've got the denominator. And now, when I FOIL this out, so I'm going to have 3 times -4 plus 3 times 7i plus 2i times -4 plus 2i times 7i. That's the numerator. The denominator, I'm going to have -4 times -4. I'm going to have -4 times 7i. Then I'm going to have my -7i times -4. And then I'm going to have my -7i times 7i. Now I can, again, just keep doing these things separately. This becomes -12. Then I'm going to have 21i minus 8i. Then I'm going to have 14 times I squared. In the denominator, I'm going to have -4 times -4, 16. -4 plus times 7i is -28i. -7i times -4 is plus 28i. And then I'm going to have -7 times 7 is -49 times I squared. And notice these things cancel. If they don't cancel, you did something wrong. And that means you need to go back and redo things. Let's see. So now I've got -12i plus 21i minus 8i. I squared is -1. So I have that in the numerator. Oops, and I messed up. That -12 should just be -12 there. In the denominator, those cancel, so I'm left with 16 plus 49. So I've got -12 minus 14 is -26. 21 minus 8 is plus 13i. And this becomes what? 55, 65. So I can think of this as 1 over 65 times the numerator. And now I can just distribute that through. And notice this is now in the form of something plus something times I. Right? I'm going to refer to this as the real part. We're going to refer to this as the imaginary part.